Hey everyone, this is the third video lecture of chapter 11, which is dual nature of radiation and matter. So I had explained you that what is photoelectric effect and what will be the graphical variations. So let us revise it once. You see this setup on the screen? This is meant for an experimental study of the photoelectric effect. I hope you have some idea of the photoelectric effect. Now, as you can see, it has an evacuated glass or quartz tube having a photosensitive plate. Let me label it as C now. This is known as emitter, and there is another metal plate A which is known as the collector. So as you can see, the emitter and the collector are attached to a battery that maintains potential difference between the plates. And can you see that there's a small window that opens up into the glass tube? It's a transparent quartz window which permits ultraviolet radiation to pass through it and irradiate the emitter. Now, monochromatic light from a source of sufficiently short wavelength passes through this window and falls on the photosensitive plate, that is C. So because of photoelectric effect, the electrons are emitted by the plate C and are collected by the plate A, which, as I told you, is known as collector. And why does it happen? It happens because of the electric field created by the battery. Now, when the collector plate is positive with respect to the emitter plate, that is C, the electrons obviously are attracted to it. The motion of electrons causes the flow of electric current in the circuit, resulting into photocurrent that is flowing in the circuit has to be measured, and that's why you have that microammeter. The photocurrent can be increased or decreased by varying the potential of the collector plate with respect to the emitter plate. The intensity and the frequency of the incident light can also be varied, and as can the potential difference V between the emitter and the collector. So let us summarize the experimental features and observations of photoelectric effect. The very first observation is that photocurrent is directly proportional to intensity of light. This is also what we have concluded from the first graphical variation. Okay, that photoelectric current is directly proportional to the intensity of the incident light. Second observation is saturation current is proportional to the intensity, but stopping potential is independent of intensity. This is the observation that whatever we have found from second graphical variation, that saturation current will be proportional to intensity, but stopping potential will be independent of it, right? And third observation is that there exists a certain minimum cutoff frequency. There exists a certain value of frequency, and above that only photoelectric emission will take place. If the supplied frequency will be more than the threshold frequency for that particular matter, then only photoelectric effect will take place, otherwise not. Fourth observation of photoelectric effect is that the emission of photoelectrons is an instantaneous process. It is an instantaneous process, means there is no time lag between the incident radiation and the emission of photoelectron. Okay, so there are four observations. First one, photoelectric current is directly proportional to intensity. Second is saturation current is directly proportional to intensity, but stopping potential is independent of it. Third is about threshold frequency, and fourth is that photoelectric emission is an instantaneous process. Our next topic is photoelectric effect and wave theory of light. Wave theory fails to explain the characteristics of photoelectric effect. According to the wave theory, energy and intensity of light wave depends on its amplitude. Hence, energy of photoelectrons should increase with intensity of light. But experimental results indicate that the energy of photoelectrons does not depend upon the intensity of light. According to the wave theory, energy of light has no relation with its frequency. Hence, change in energy of photoelectrons with the change in frequency cannot be explained. Photoelectrons are emitted spontaneously. This cannot be explained by wave theory. Free electrons in a metal are emitted only when it gets certain minimum energy called work function of the metal. If the light has wave nature, free electrons in metal may get energy gradually and some time elapses before it gets energy equal to its work function and gets emitted. This is in the contradiction to the spontaneous emission. With less intense light, the emission of electrons will be slower as per the wave theory. But with the light of sufficiently high frequency, emission of photoelectrons is immediate even if its intensity is low. Einstein's photoelectric equation of quantum radiation. In 1905, Einstein explained the photoelectric effect using Max Planck's quantum theory. Planck had assumed that the emission of radiant energy occurs as photons. But after emission, it transmits as a wave. Einstein assumed that the emission, transmission, and absorption of light takes place in the form of photons. According to Einstein, when light in the form of photons are incident on a metal, it is totally absorbed and its energy is partly utilized to free the electron from the metal surface as work function, and the remaining energy will be imparted as kinetic energy to the ejected electron. Thus, energy of photon equals to work function plus K maximum. E is equal to phi naught plus kinetic energy maximum. H nu is equal to H nu naught plus kinetic energy maximum. So kinetic energy maximum will be H nu minus H nu naught, and this equation is called as Einstein's photoelectric equation. Now our next topic is Einstein's photoelectric equation, that is energy quantum of radiation. So basically Einstein photoelectric equation is K maximum, which is what? The energy of the ejected electron. It is equal to H nu. What is H nu? H nu is the energy of the incident photon minus phi naught. And what was phi naught, everyone? Phi naught was work function. Okay, so this equation I have explained you already that energy carried by electron will be what? It will be the left out part of the energy. Means, let us suppose you are supplying 16 eV. 7 eV is used by the metal as its work function. So electron will be carrying how much? 9 eV. That will be its K maximum. So K maximum is equal to H nu minus phi naught. Okay. Now intensity of light of a given frequency is determined by the number of photons incident per second. I have told you that intensity is what? It is number of particles per unit time per unit area. Increasing the intensity will increase the number of emitted electron, right? However, maximum kinetic energy of the emitted photoelectron is determined by the energy of the photon. I have told you already that K maximum depends on the energy of the incident photon. More will be the energy of the incident photon. Energy is what? H into nu. H is a constant. So either you can call it as energy or you can call it as frequency of the incident photon. More the frequency, more will be the kinetic energy. Okay, and this equation which I have highlighted, this equation is known as Einstein's photoelectric equation. This equation is known as Einstein's photoelectric equation. Since this K maximum in the equation must not be non-negative, for that, see, it is on left hand side and on right hand side we are having subtraction of two quantities. If I want left hand side to be non-negative, it means right hand side must be non-negative as well. So to make right hand side positive, what do you need? As it is subtraction of two quantities, then you need h nu must be greater than phi naught. H nu must be greater than phi naught. And what is phi naught? Work function. Work is what? Energy. So it can be written as h nu naught. Phi naught can be written as h nu naught. So h nu must be greater than phi naught, and phi naught can be written as h nu naught. H and H will get cancelled out, means nu must be greater than nu naught. This is already we have seen that given frequency or supplied frequency must be greater than threshold frequency, right? Okay. Now third point is saying that greater the number of energy quanta available, means energy quanta means what? Photons. So greater the number of incident photon, greater is the number of electrons absorbing energy. So greater will be the number of ejected electrons. Okay, it means photocurrent is directly proportional to intensity. So means Einstein photoelectric equation is again concluding all the points that we have seen experimentally. So this is correct. Okay, this is valid. Now Einstein picture, the basic elementary process involved is what? Absorption of light quantum by an electron. So this is instantaneous. It means Einstein's equation prove that this photoelectric effect is instantaneous process, and the same has been observed experimentally. So means the equation given by Einstein is perfect. Okay. So instead of K maximum, we have seen one formula. I have told you also to keep it in your mind as it will be beneficial for you for numerical purpose. K maximum will be written as EV naught. K maximum can be written as EV naught. So Einstein photoelectric equation will become EV naught is equal to h nu minus phi naught. Okay. So what I have done in the next step, E on the left hand side we have taken it to the right hand side. So equation will become V naught, which is equal to h by E nu minus phi naught by E. So if you are going to compare this equation, it is equation of straight line. It is an equation of straight line, and straight line equation is what? Y is equal to mx plus c. Y is equal to mx plus c. Y means the parameter taken along y-axis. So if you compare both the equations, y is what? V naught. Y is what? V naught. M means slope. M means slope, which is what? H by E. What is x? X is the variable taken along x-axis, and if we compare, then Rx is what? Nu, that is frequency of the incident photon. What about C? C is the intercept, means it is a point where the line intersects the y-axis, and C is how much? Minus phi naught by E. Graph was not there in your book, so I have taken it and I have pasted it over here. As you can see, two parameters are there. If you compare, Y is what? V, that is potential, stopping potential rather, and x is what? Frequency of the incident photon. Then graph will be a straight line because it is matching this equation. Y is equal to mx plus c. Slope, gradient is written h by e, that is slope. Okay, and v is equal to minus w by e. This is what? This is minus of work function. Work function means phi naught by e. This is intercept. We can also see it from this equation. C is how much? Minus phi naught by E, and here it is represented minus W, means you can represent it as either phi naught or W. Okay, and one more thing I would like to tell you, that here one more point is mentioned, that is nu naught. It is mentioned on it is mentioned on x-axis. It is mentioned on x-axis. So this point means we know that on all the points on x-axis, y is always 0. Y parameter is always 0. So how to find this point nu naught on the x-axis? What we have to do? We have to equate y parameter with 0. Means v naught you have to make it 0. If you will make it 0, left hand side will be 0. Take this minus phi naught by e to left hand side. Minus phi naught by e to the left hand side. It will become positive. So for the time being you are having phi naught by e equals to h nu by e. E is in division on the both sides, so that will be cancelled out. So you are getting nu, which is equal to phi naught by h. Nu, which is equal to phi naught by h, and here they have written w by h. Phi naught by h or w by h, one and the same thing. And this point is what? This point is what? At which this is 0. Stopping potential is 0. That point is called as threshold frequency. That point is called as threshold frequency. So what happened basically, Millikan performed a series of experiments on photoelectric effect. Basically his aim was to disprove Einstein photoelectric equation. So what he did, he measured the slope of the straight line for sodium, okay, similar to as shown in the figure, okay. So using the known value of E, he determined already known value, which was Planck constant, and he found that the value was coming exactly or very close to the value of Planck constant, and the value of Planck constant is 6.26 into 10 raised to power minus 34 joule second. 6.626 into 10 raised to power minus 34 joule second. So therefore, with the aim to disprove Einstein photoelectric equation, he proved Einstein right, and both were awarded Nobel Prize. Einstein was awarded in 1921 and Millikan was awarded in 1923. So this was all about this video lecture. What you have to do, you have to try the solved examples from 1 to 22, and if any doubt is there, do let me know in the comment section below. Thank you so much for watching this video lecture.